Hi, this is Mr. Mac. We're talking today about quadratic inequalities. Now, the way we're going to handle this is we're going to start out by talking about how you would graph a quadratic inequality in two variables. Let's imagine we have a quadratic inequality like y is greater than or equal to x squared minus 5x plus 6. Okay, now, one of the foundational concepts of graphing inequalities in two variables is the equation that you get if you ignore the inequality sign and put an equal sign there is going to be the boundary between the points that do satisfy the inequality and the ones that don't. If you have a greater than or equal to or a less than or equal to, when you graph it, you'd graph it as a solid line or curve. If you have simply greater than or simply less than, you graph it as a dotted line or curve, and that means that it's the points up to but not including the curve. When you graph it as a solid curve, that means that the points on the curve also satisfy it. So what we do first in graphing inequalities is we kind of forget that we have an inequality sign, and we just think to ourselves, okay, we want to graph y equals x squared minus 5x plus 6. Now, if we were to do that, then we know lots of ways by now to graph these things. One way to do this would be to find the vertex and then find some other points. Now, if, for example, we decided to do it that way, we know the x value of the vertex, h, is negative b over 2a. Now, in this case, b is negative 5, so it's negative, or the opposite of negative 5, and a is 1 over 2 times 1. Now, that's 5 over 2, or 5 halves. And then k is going to be the value that you get when you put 5 halves in for x. So we have 5 halves squared minus 5 times 5 halves plus 6. And 5 halves squared is 25 fourths. Negative 5 times 5 halves is negative 25 halves. And then 6, we're going to be doing this in fourths, so I'm going to make 6 into 24 fourths. And so this becomes 54, this middle term, 25 halves, becomes 50 over 4. So 25 fourths minus 50 fourths is negative 25 fourths, plus 24 fourths gives us negative 1/4. So we know the vertex is at the point 5 halves, negative 1/4. So if we were to sketch that, 5 halves is 2.5, and so we're down here, right about there. Now, if we plot other points, another point that you can almost always get real quickly if you've got standard form is that this is the place where the graph is going to cross the y-axis. In other words, 6 is going to be the place where the graph crosses the y-axis. And since we've got an axis of symmetry, 2.5 units to the left of the axis of symmetry, we're at 6. So 2.5 units to the right of the axis of symmetry, we would also be at 6. Now, that probably will give us enough points to sketch in the graph. You could plot more if you wanted to, but that's pretty much what the parabola is going to look like. Now, we're trying to graph the quadratic inequality. We found what the edge looks like, and we've graphed it as a solid curve because we have greater than or equal to. And now the question is, which side do we want to shade? Do we want to shade inside the parabola, or do we want to shade outside the parabola? Once again, the easiest thing to do is to find a point that's not on the curve, and if 0, 0 is available, I recommend you use it, and put it in and see if it makes it true. Well, when I put 0, 0 into this inequality, I get 0 is greater than or equal to 6. And that's not true. So we do not want to shade the side of the parabola that contains the origin. So therefore, we would be shading the other side of the parabola which would be inside. And so let's see how I can do here. Shading. That would be a graph of a quadratic inequality in two variables. Okay, now there's a related question where we have quadratic inequalities, but we don't have a y. Now, folks, please, as you're going through this, try not to get these confused. Always make sure that you understand when you look at the problem where you start with, that you know which way to go, what you're actually trying to accomplish. So let's take a look at a quadratic inequality in one variable, and I'm going to use one that's very similar to the one that you just saw. Let's use x squared minus 5x plus 6 is less than 0, okay? Now, what we can do now is we can solve this by graphing. And what we do is we think of the x, well, first of all, again, if it isn't less than or equal to 0 or less than 0 or something like that, move everything to one side so that you've got a quadratic polynomial on one side and a 0 on the other side. And what we do is we think we're going to let that equal y, or y is equal to that. And if we were to do that, then we would get a graph. And actually, if you refer back to the earlier part of this lecture, we had a vertex at 2.5, negative 1/4, and it went through 6 on the y-axis, and it went through 5, 6 as well over here, the symmetric point. But now, what we want to know is where y is less than 0. Now notice y in a graph is the length of the line segment from the x-axis to that particular point. Now, if we want y to be less than 0, then we want the values where the parabola is below the x-axis. Now, what we want to report is what x's will give us values below the x-axis. So we need to know where the graph actually crosses the x-axis here. And then notice what we're going to do is we're going to take the values between those two. Now, we know a lot of ways to find the zeros of quadratic polynomials. We could maybe use factoring or completing the square or the quadratic formula. I'm going to just factor in this particular case. If we take x squared minus 5x plus 6 and we factor this, notice we're looking for two numbers that multiply to give positive 6 and add to give negative 5. Well, that's negative 2 and negative 3, because negative 2 plus negative 3 is negative 5, and negative 2 times negative 3 is positive 6. Now, the zeros are the numbers that you would put in for x to make each of those binomials equal to 0. So the zeros are 2, because when you put 2 in for x in the first binomial, that makes that 0. And when you're multiplying, it doesn't matter what the other number is. 0 times anything is 0. And 3, because when you put 3 in for x, the second binomial becomes 0. And if you're multiplying, notice you're multiplying right here, it doesn't matter what the other number is, because 0 times anything is 0. So the zeros are 2 and 3. Now, if you look up here, do we want the values where it's 0? No, we don't. So we would put an open circle at 2 and an open circle at 3. Now, we then say, do we want the part of the parabola that's above the x-axis? That would be when the parabola was greater than 0. Or do we want the part where it's below? Well, we want the part where it's below. So we would take the values in between, and the solution to this quadratic inequality would be 2 is less than x is less than 3. Now notice a very different result from the quadratic inequality where we had two variables, x and y. Okay. Now we did graph the quadratic polynomial anyway to help us here. This is called solving quadratic inequalities by graphing. Now we can also do it algebraically. And if you'll look at this, it's really pretty easy to see that if you want to solve one algebraically, then what you're going to do is you're just going to find the places where the zeros are, and then okay, well we'll go on from here. So let's take another quadratic inequality, and we'll solve this one algebraically. And let's pick one that may be a little bit more confusing. How about x squared minus 10x plus 22, and let's say we want this to be greater than or equal to 0. And we're going to solve this one algebraically. Now, the idea is there is, this is a quadratic polynomial, and it has as its graph a parabola. But what we're really interested in is where this graph crosses the x-axis. In other words, where the zeros are. And we can find that by, well, in this case, let's use the quadratic formula. The zeros are at x equals 10 plus or minus the square root of 10 squared, that's 100, minus 4 times 1 times 22, that's minus 88, all over 2. Now let's do a little bit of simplifying here. We get 10 plus or minus the square root of 12 over 2. And you and I both know that 12 has a factor of 4 in it, and the square root of 4 is 2. And the 3 is not a perfect square, so it has to stay inside. Now there's a factor of 2 in both terms in the numerator, so we end up with 5 plus or minus the square root of 3. Now, that means that the quadratic polynomial is 0 at 5 minus the square root of 3 and at 5 plus the square root of 3. Now, we don't really know, so far at least, what these numbers are equal to, but you could put them in the calculator. We may as well just guess here. Now, the square root of 3 is somewhere between 1 and 2, because the square root of 1 is 1, square root of 4 is 2. So this number, 5 minus square root of 3, is actually going to be greater than 5 minus 2 or 3. So a number over here like 0 would definitely be to the left of 5 minus the square root of 3. What we're going to do is we're going to identify an easy number to work with that's inside each of these 3 regions. Now, it's pretty clear that 5 is between here. And if we add 2, we get 7. So 10 would definitely be in this region over here. Now, since 5 minus the square root of 3 is a 0, and we do want the places where it's equal to 0, we're going to put a closed circle on 5 minus the square root of 3, and we're going to put a closed circle on 5 plus the square root of 3, because we do want those 2 values. Now, the question is, do we want the values, which of these intervals do we want the values in? And so what we're going to do is we're going to put these values back in the quadratic polynomial. We've got x squared minus 10x plus 22. If I put 0 in, I get 0 minus 0 plus 22, and that is greater than or equal to 0. So we do want this region over here. So I'm just going to fill this in here and put an arrow over here. Now let's try 5. We tried x equals 0 here. If x equals 5, then we have 5 squared, that's 25, minus 10 times 5, that's minus 50, plus 22. That ends up being negative 3, which is, we want it to be greater than 6, so it's not. So we don't want that region there. We're not going to take this region here. Now we can try x equals 10. 10 squared is 100, minus 10 times 10, that's another 100, plus 22. That's greater. We want it to be greater than or equal to 0. It is, because we get 22. So we will take this region here. So I'll fill this in, and I'll put an arrow over here. So we would algebraically say that x is less than or equal to 5 minus square root 3, union x is greater than or equal to 5 plus square root 3. And that would be how you do these things algebraically. Once again, let me recap here. When you do it algebraically, you take the quadratic polynomial, locate the zeros on the number line, find a number in each of the regions identified by the zeros, test them and see which ones actually make it true, and those are the regions that you want. And that takes care of quadratic inequalities.